Hi everyone, my name is Alex. Let me say a few words about myself. I'm a developer with an enterprise background. I spent the last 7 years in game development working with Unity. And for the past year, I've also been working on pet project in NIM called Brutanks. And today, I'll briefly cover the game as a product, dive a bit into the architecture, and explain why I chose the NIM stack. So what is the game about? At its core, it's a multiplayer web top-down shooter similar to Deep.io, but with advanced graphics and RTS elements. The game has two main mechanics. Arcade part, the core mechanic. The player builds a tank to suit his playstyle and a specific tactic. It can be heavy, slow tank, a fast, agile one, or one specializing in mines, drones, more efficient resource gathering, and so on. Then, player goes into battle against other players, relying on his reaction speed, ability to predict projectile trajectories, and other tactical skills. RTS part, an additional mechanic. This involves gathering resources and building up the team base. Buildings and upgrades allow players to unlock new tank parts. At the beginning of game session, only light tanks are available, which struggle to capture the enemy base. The fight is for capturing and holding resources on neutral territory. At later stages, collected resources are put into base development, allowing players to field advanced and heavy vehicles that can destroy enemy defensive structures and turrets more easily. Thus, the outcome of battle is determined not only by players' piloting skills, but also by team strategy, where each player contributes to the whole team's progress. The visual style is pen and paper with pale watercolor. The game is planned in two versions, a simplified web version first, and later a Steam version with deeper mechanics, such as perk system and RTS features. So, that's Brutanks as a product. Now a few words about architecture. As I said before, Brutanks is a multiplayer game with clients and dedicated server. Clients send user inputs to the server. The server performs calculations and sends simulation results back to the clients, which only render the received data. For data transfer, I used compressed DTOs. For example, rotation angle is sent as 2-byte int. Position data is compressed vector of 6 bytes, and so on. Additionally, objects are called by square distance. If an object is far from player's camera, the player simply doesn't receive its position. This way, a single session can host up to 100 players and more. The client is written in NIM. It uses NAC as the render engine and Proton as an ECS framework. Server is also written in NIM and also uses Proton. For physics, I use a wrapper around Box2D and Mami for networking. Let me elaborate on Snack and Proton. Snack is a simple, high-performance web-first 2D engine written in NIM. It's similar in functionality to XNA. There is no built-in editor, but you can easily build tools for game designers or level designers. For example, we have a map editor built in JS that outputs JSON, which the server loads on startup. One of Snack's distinctive features is the ability to build UI using HTML and CSS rendered on top of the game. It also includes a networking model and math library. Content is prepared and distributed in bundles. All sprites are automatically converted to WebP format. The compression level can be adjusted per bundle. The rendering order of content is defined by the user. In my case, I have a dedicated render ECS system, and every entity has a component with its render data. This way, the rendering is fully integrated into main ECS pipeline, and it's quite convenient. Proton, an ECS framework for NIM, created by the author of ECS Lite and Proto ECS. A quick note on ECS. It's an architectural approach used mainly in game development. It frees you from excessive abstractions, complex hierarchies, such questionable things as solid, and endless refactoring when a new feature doesn't fit your perfect design. Plus, it usually gives better performance, and that matters a lot in game dev. Proton is actually an import of Proto ECS, which is in my opinion the best ECS framework for C#. More information about Snack and Proton is available at official chat. That's basically everything needed for what exists so far. So why NIM? First, performance. On my machine, the Znak bunny mark test runs at more than 500,000 moving sprites in the browser at 60 FPS. I found similar bunny mark for Unity and it dies after 20,000 sprites on the web build. So in this case, Znak is an order of magnitude better than Unity. Physics performance tell a similar story. Unity starts to struggle at around 3000 boxes, while Znak with Box2D wrapper handles 10,000 or more without breaking a sweat. This significantly expands the range of devices that can run the game. Office laptops and lower-end hardware are now viable. The second reason is build size, a critical metric for the web. The binary without content is 200 kilobytes. In Unity, that would be around 10 megabytes. The third reason is open source with no monetization or licensing risks. You may have heard about the Unity runtime fee feature. And the last point, probably the most important one for me personally, is the language itself. After years with C# and Unity, writing in Nim is generally more enjoyable. Thank you for your attention. You can also join our Discord server to follow the progress and take part in the development.